Welcome everyone. Thank you so much for joining us today. My name is Gillian Stephen and I'm the segment manager for Twinkl Scotland Primary. Before joining Twinkl, I was a primary school teacher for about 9 to 10 years and then came and joined Twinkl, and I've done a range of jobs here, from creating the resources that you use in your classroom to running social media before becoming segment manager, and that was with return to the classroom and jumping about. And I now do a bit of both, where I work 1 day a week in a classroom and still do Twinkl full time as well. I'm absolutely delighted to introduce today's speaker, which is Chris McKenna from Count On Us. We met many years ago at the Scottish Learning Festival, where we had our little booths beside each other, and I just loved all of his ideas and the way that he is able to just develop numeracy and maths for younger children and for primary children, which I just think is obviously very important and something that, as a child learner, I always struggled a little bit with numeracy, and as a teacher, I always am looking for new and exciting ways that I can engage children in maths. So hopefully today you'll all see what I saw when we met, and I'm really happy that we've finally been able to do something like this, because it's been a long time coming. So I'm going to turn off my screen and pass you over to Chris. So I know it said it was led by us both, but really it is all down to Chris today. And I hope you enjoy the session. Thank you so much. Over to you, Chris.
Thank you, Gillian. Thanks everyone for coming along. So my name's Chris McKenna. So I've been teaching for 20 years now. Spent 13 years at Kehl Academy as a secondary school math teacher, but part of that kind of in the last few years there, I was a numeracy development officer for South Ayrshire Council, where we delivered lots of kind of numeracy training across the South Ayrshire cluster, involving number talks and the numeracy box and stuff like that. So, and then I decided to start Count On Us education, where I specialised in kind of this resource. Basically, this is the main resource that I use to teach with. I'm just going to try and get that up to the screen. So this is the Numeracy BluePrints board. It's the new version. It can basically flip out like this, and it's kind of folds out to A3. I'm trying to find the best way to show you this. It folds out to A3, but when you fold it in, it goes to A4. So that's the kind of latest version of the whiteboard. So everything I'll show you today can be done using this board, but obviously you don't need the board. It's just things like 10 frames and 100 squares and so on. So hopefully you enjoy this session. I'm basically going to, most of the things I'm going to do, so we're going to focus on the 4 operations. I'll start at kind of early level and I'll progress up to kind of second, third level. So you can hopefully see the kind of journey no matter what stage you're teaching at. So let me get started. Right, so again, this is the kind of the lead screen, and I'm just going to quickly go over the aims and objectives. So upskill pedagogical knowledge around numeracy, increase awareness of visual and active learning activities, like the principles of concrete, pictorial, abstract. And hopefully what's today going to involve some fun, right? Because you're going to get the chance to do some tasks, interactive tasks involving maths and numbers. Some challenges that prompt our thinking and learning something new. Now that might be me learning something new. So that's what the Q&A bit's all about. So any questions or any ideas that you have following on from what I do, please share them with the gang. So I'm not going to read all that out, but that's hopefully everything we're going to kind of look at today: subitizing, patterns and so on, more subitizing, number bonds, adding, subtracting. But the main thing that I'm going to talk about to start with is 10 frames. And when I'm working with the children, I tell the children I like 10 frames, I like making 10, and I like using 10s as a reference point. And one of the main activities, especially even you can do this in the early years, nursery, subitizing. So what is subitizing? Well, just looking at that picture there, we can tell me that it's 3 dots. If you're a very young learner at age 3 years old, they might count at 1, 2, 3. But eventually, once we go up to primary 1, we want children to be able to subitize, to recognise that amount as soon as they see it. So I know the microphones are off, but I hope you're shouting out the answers behind your laptop or phone, wherever you are, if you're at school or if you're in your house somewhere. So shout out the answers as we go along. How many dots do we see? 4. Good. How many dots do we see? 6. Good. How many dots do we see? 10. And I use a special, I call that a total 10. So when I'm working with the children, I say, like, that's every dot in the 10 frame, sorry, every box in the 10 frame has got a dot. So I'm going to call that a total 10. How many dots? So we've covered up one side of the 10 frame. That's a fast 5. And again, I'll use that language of the children. I don't want them to go 1, 2, 3, 4, 5. I want to spot that's a fast 5. How many dots this time? We have 7. So it's a fast 5 and an extra 2. How many dots this time? Shout out, remember, at home. Make sure you're participating. 13, a total 10 and an extra 3. How many dots this time? It's 9. Is it, again, I'll ask the question with the children, is this a total 10? No. Why is it not a total 10? Because there's 1 dot missing, so it must be 9. How many dots now? 18. Good. How many dots now? Hopefully you all got 43. There are 4 total 10s and there are 3 1s, so the answer is 43. And this activity, although I'm not going to go into it here, this is good for place value. So no matter what number how many dots you draw here, it's good for looking at your place value. How many 10s, how many 1s. Are you ready for the next one? Yes, good. You thought you were ready. What happened there? So I've made it a wee bit more difficult. I've took away the structure of the 10 frames. So what if I do this? So that was the picture a second ago. That's the picture now. Does that make it easier? Yes, because straight away I've grouped it into 5 reds, 5 yellows, 5 greens. So it's 15. 3 blues makes 18. So when we take away the structure of the 10 frames, subitizing becomes quite difficult. So that's why I like the 10 frames, using 10s as a reference point and using the total 10s. And we're going to use that for addition, subtraction, and you'll see how important I think it is. So again, somebody who I used to work with is at this meeting just now. Hello, Val, if you're there. I saw you signed in. So Val's asking the question, what can we do with children who are kind of struggling with the basics? Val's a secondary school teacher in the Learning Support Department at Kelly Academy. And this is one of the main things I would do. So I would find out, does a child know how to subitize even numbers like going back that? Do they know rapidly that's 9? If they don't, then I would spend some time working on that. Right, some nice wee activities we can do down the early years. I might give the children, hopefully the children will have a board in front of them. Say, okay, can you draw 8 dots on one of the 10 frames? So say, go ahead, draw me 8 dots on one of the 10 frames. And we're going to have a conversation of how many different ways we can do it. So some child might say, okay, I've drawn my 8 dots like this. So I will then get them to do this wee numbered one picture and say, right, okay, how did you make your 8 dots? Well, my 8 dots are made up of 5 on one side and 3 on the other side. So notice I'm not writing anything abstract right now. I'm not writing 5 plus 3 equals 8. We're just drawing a numbered one picture to start to understand the relationship of the number 8. We might say, oh, actually, yeah, I did draw my 8 dots like that, but I looked at it slightly differently. I could see 6 dots up the top and 2 dots down the bottom. So my number 8, I'm looking at it as 6 and 2 rather than 5 and 3. You might have drawn your dots differently altogether. You might have said, look, well, I actually drew 4 dots on this side and 4 dots on that side to make my 8 dots. Or you may actually have drawn the same picture, but you can see, well, actually, when I draw the number 8, I can see it as 4 lots of 2, so it's 2 plus 2 plus 2 plus 2. And obviously, again, in any activity you do, it's good just, okay, the question there was draw 8 dots. Right, but it was the discussion you have afterwards, wasn't it? So it was 5 and 3 dots, it was 4 and 4 dots, it was 6 and 2 dots, or it was 2 and 2 and 2 and 2. Okay, so from one activity in the class, draw me 8 dots, we can start to generate quite a lot of discussion about how the number 8 is made up. Somebody might actually say, well, it's a total 10. It's 2 boxes empty. A nice task to do with children as well is write the numbers 1 to 10 in the 10 frames. And again, if you think about that yourself, how would you write the numbers 1 to 10? Basically, two different ways we can do them. We can start to go down like that. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we go all the way up to 20, this is what we get. And again, ask the question, what do you notice? We're not going to just do an activity or a task with children and then rub it out. So say, what do we notice here? And hopefully, we might get some good answers. So actually, look at down the bottom. We've got 5, we've got 10, we've got 15, we've got 20. So that's the start of my counting 5 numbers. We might say, actually, well, there's a 2 in here and there's a 7 in here. There's also a 2 in here and a 7 in here. What is this going up in? 3, 8, 13, 18. That's also going up in 5s. It's not the nice 5, 10, 15, 20, 25, 30, but 3, 8, 13, 18, it's still going up in 5. I'm seeing a few questions pop up, so we will try and answer those at the end. If Gillian or Louise think it's an important question, just unmute yourself and ask it up. Thanks. And again, what I like to do is ask, what if we had another 10 frame here? What would the next numbers be? So what would we expect in this next box here? So 1, 6, 11, 16. What would we expect in here? Another way to write the numbers 10 is going across the way. So we've got 1, 2, 3, 4, 5, 6, and so on. And again, what do you notice? What do you spot here? Well, what we spot here is we've got 2, 4, 6, 8, 10. We've got the start of the even numbers. On the other side, we've got 12, 14, 16, 18, 20. And of course, then we've got the odd numbers on the other side, 1, 3, 5, 7, 9. But again, we spot the same thing. There's a 3 in here. There's a 3 in here. There's a 4 in there. There's a 4 in there. What would we expect in the next 10 frame? So to draw a 10 frame next to this, or put another board beside it, say, right, what we expected in, what numbers are we expecting in this 10 frame? On the Numeracy blueprint board, we have 100 square somewhere, and we also have a vertical number line or a number track. And again, if I was down in the early years and in first level, I would be sticking to using the number track or the number line, just so we can see if I look at the number 7 and I say, let's point at the number 7. What number is above 7? We say the number above 7 is 8. What number is below 7? It's 6. I can look at the number 17, say, right, what's 2 places higher than 17? What's 2 places lower than 17? And again, the 100 square is a really good resource, but again, if you're a young learner, the 100 square can be quite busy. And if I say to a child, what number's next to 17, then they could give me a variety of different answers. So until children are really confident and secure with structure and the number order of numbers, I would stick to to using the number track before we go on to explore patterns or anything on the 100 square. Right, back to a wee bit of subitizing. So again, we talked about subitizing a little bit. So when I'm doing this with the children, so I might just draw some dots on the board and show them the board, or I'll have some kind of ready-made kind of presentation with it. But eventually we'll get to start saying, okay, can you draw me 8 dots? Okay, let's draw me 8 dots. And we'll say, okay, right, what I want you to do now is cross the out. And again, when I'm starting this, I always like to cross them out rather than rub out, because I can still see the original 8. If I cross them out, I can see I've crossed out 3. And I'll say, right, how many am I left with? I'm left with 5. And then I might start to get children to actually write down the abstract part. Okay, so we started with 8, we subtracted 3, and we ended up equaling 5. So write 8, take away 3 equals 5. And it's nice to tie that in with the number track. We can say, okay, 8 subtract 3, so we go down 3 places, and we can see the answer equals 5. Again, looking at some more kind of linking to subitizing, we'll say, right, I've got 9 dots here, I've got 6 dots there. But I'll ask the children, right, when we looked at numbers bigger than 10 earlier on, we normally had a total 10. So we've got 9 blue dots, we've got 6 red dots. How many dots do we have altogether? But I would ask them the question, like, can I make a total 10? And quite quickly, somebody say, yeah, and it's good. This is a good activity to do with counters, and say, okay, right, we can slide one of those counters along. So there's 6 red counters, but I'm going to slide one down there. So although we're looking at 9 add 6, what I'm really changing the question to is 9 add 1 add 5. Why did we do that? Because we made the total 10. And again, that links back to the subitizing that we did right at the very start there. So if I'm going to teach a child how to do 9 add 6, I would want to make sure they're really good at subitizing within 20. And then they can start to piece that together. Eventually, I wanted to get them to kind of know that process in their head, or not just in their head, but be able to kind of jot it down without the dots. And this is what the empty number line is really good for. So we started at 9 and we were adding on 6. We added 1 onto the 9 first of all to make the total 10, and then I added the other 5 to make 15. So again, this is a nice wee kind of empty number line, a nice wee way to keep track of the strategy there without actually having to draw the dots out every single time. So the more practice we do with the dots or the counters and so on, eventually say, right, do we need to draw them all the time, or can we try and do this kind of empty number line addition process where we bridge through the 10? Similar question, 9 blue dots, 8 red dots. How many dots are there altogether? Can I make a total 10? How can I make a total 10? Well, we can do the same process we did earlier, and we can move 1 dot across. So instead of being 9 add 8, it becomes 9 add 1 add 7. You can see the answer is 17. I could change it up and say, okay, how many blue dots, how many red dots? 8 blue dots, 5 red dots. Can I make a total 10? Yep, I can move 2 across. So instead of doing 8 add 5, we're doing 8 add 2 add 3. Again, we're getting a total 10. And again, I would link back to the empty number line where we're doing 8 add 5, but I did 8 add 2 add 3. 8 add 2 got me my total 10, add 3 gets me 13. Then we can start to do it with bigger numbers. We can start to go, instead of the single digits, we're looking at a 19 plus a single digit. And we're saying, okay, can I make a total 10 again? Can I move one of those red dots up to make a total 10? Yep. And I only need to move 1. So instead of doing 19 add 6, we're looking at 19 add 1 add 5. Again, I would link into the empty number line. 19 add 1 gets me the next total 10. Add the other 5 gets me 25. We can even branch up. So obviously you can see here that we've looked at subitizing. I'm quickly just showing you how we can link that right up the stages just now. Okay, so we have to be really good at subitizing, and we have to be secure at single digit. And then we're saying, right, if we're good at single digit, can we do 19 add 6? If we're confident in that, right, can we jump all the way up to 39 add 28? And again, I'm going to stick with the same strategy. Lots of different ways we can do this. 39 add 28. I'm going to stick, just for this presentation just now, I'm going to stick with the kind of total 10 strategy. So I'll again asking, can I move that dot up into this spot here? Yep. Okay, so let's move. How many dots I need to move? I need to move 1. So although it's 39 add 28, I'm thinking of it as 39 add 1 add 27. So that makes me 40. I can see the answer 67. And again, I would like to record that on the empty number line. 39 add 1 was 40, add the other 27, 67. And then finally, we can jump up to a question like this. We can say 398 add 27. So again, we start at 398, we add on. So again, I would ask the children here, right, 398, how close am I to the next total 10? Or what do I want to land at? So 400 is a nice friendly number. So we're only 2 away. So if I do 398, I add on 2, that gets me to 400. I add how much, I still want to add on 27, so I need to add on the other 25. So what's the final answer? The final answer is 425. So you can see how that links into the 9 add 6, the very first kind of addition question we looked at. And again, it's building up over the years to be able to understand and do this type of question. Right, so that's basically a quick fire kind of process of the addition, one of the main 4 operations. And again, hopefully you can see the importance of the subitizing with that so that they can help understand making that total 10. So now there's 11 dots, and I want you to imagine, well, I'm going to cross out 2 dots, okay? So I want you to think to yourself, what 2 is Chris going to cross out? Okay. So I'm going to cross out those 2. Most people will probably agree with me. That's the 2 dots they would have crossed out. There's always a wee difference. Some people cross out the top 2. That's fine. But I think when I do this presentation live, there's normally 90 to 95% of people cross out those 2 dots. There's now 13 dots. I'm going to cross out 9 dots. I want you to think, which 9 am I going to cross out? Now, when I do this question, it normally splits the room more down the middle. Maybe not 50-50, but 60-40. Some people continue with the same strategy, like the 11 takeaway 2. That was the last dot I drew, so it's the first kind of dots to go. 30 takeaway, some people stick to that one, so those 3 over there, well, I'm going to get rid of those 3 first of all. Then I need to get rid of another 6. So it doesn't matter which 6 it is, but I need to get rid of 3 from here. I need to get rid of 6 from there. So I'm subtracting, or I'm crossing out across 2 10 frames. Again, that's kind of, it's normally 50-50. But some people think, well, no, it's easier to cross out 9 dots all in a one up from the 1 bit, like that. But there's not 13 takeaway 9 normally kind of, as I say, it splits the room 50-50. Each strategy is just as efficient. But what I'm going to do is I'm going to focus in on this strategy for a few examples, because I think it's really important as a count up strategy. So what you're really doing here is you're more changing this one to an addition. You're thinking, if I'm at 9, how am I getting to 13? Or you're thinking of it as a difference between 9 and 13. And again, this is where the empty number line comes in. So if there's 9 and there's 13, I'm going to introduce that yellow spot. It's going to stand for 10, because I like 10s. I like using 10s as a reference point. So the difference between 13 and 9 is those 2 jumps there. That's 1, that's 3. So the difference between 13 and 9 is 4. So now we're going to look at a more complicated example. So if you can see on the screen, how many dots are there? There are 53, 5 total 10s with 3 1s. How many have I just covered up? Covered up 19. How many dots are left? Well, there's 1 dot here, 10 here, a total 10, a total 10, a total 10, and 3. So I started with 53, I scored out 19, I'm left with 34. Now, I deliberately scored out the first 19 because I wanted to keep it like that strategy we just did for take away the first 9 when we did 13 take away 9. So that one there, I wanted to keep it similar to that strategy there. So 53 take away 19 by crossing out the first 19 dots leaves me 34. Now I want to copy that strategy onto the 100 square. So what did I do? I scored out the first 19 dots. So here I'm going to score out the first 19 numbers. And what I'm going to do is I'm going to count up to 53. So I'm going to start boxing all the numbers up to 53. So I boxed that one there and I put 1 at the side. There was only 1 number I had to box. I'm going to box these 10, put a 10 at the side. Box those 10, put 10 at the side. Box those 10, 10 at the side. And box those 3, put 3 at the side. 1, total 10, total 10, total 10, 3. If I go back to the last slide, it was the same numbers. Now, why did I do it on here as well as doing it on the 10 frames? Because this column here is my total 10s. What was the first total 10 I boxed? It was 20. What was the last total 10 I boxed? It was 50. So now I can put this strategy onto the empty number line using all these numbers. So 53 take away 19 at either side. 20 and 50 is my kind of friendly numbers or my reference points. So there's 53 and 19 on the empty number line. There's my 20, there's my 50. I'm going to count up or bounce up or look at the difference between 19 and 53. So I'm going to put that jump in there, which is 1. Put that jump in there, which is 30. Put that jump in there, which is 3. And I can see the total difference is 30, 1 and 3. So it's 34. So that was 3 different ways to do the same equation, looking at the dots, looking at the 100 square, and eventually linking into the empty number line. And again, it's good to do the 100 square because children get to see where these numbers come from. So let's look at another example. So we can see we have 74 dots. We can see that I have covered up. I hope you're still shouting out the answers back in behind your screen there. Oh, somebody's put a thumbs up there and they're still shouting out. Good. 74. I've removed 28. What's left? 2, total 10, total 10, total 10, total 10, 4. So I'm left with 46. And again, I deliberately scored out or rubbed out the first 28 or covered up the first 28 dots. So I'm going to do the same in 100 square. I'm going to score out 1 to 28 and count up to 74. So let's do that. Score out 1 to 28, cover the box all the way up to 74. I'd imagine these slides will all be sent out to you afterwards. So if you think I'm going quite fast, whatever, don't worry, you'll get a chance to see these slides. And if not, there's lots of stuff on my website as well. You can look at that. So anyway, there's the numbers 2, 10, 10, 10, 10, 4. That's my total 10 column. What was my first total 10 I bubbled? It was 30. What was the last total 10 I bubbled? It was 70. So let's use these numbers on the empty number lines. 28, 74, total 10, 30, total 10, 70. And then I'm going to count up the way I look at the difference. The difference there is 2, the difference there is 40, the difference there is 4. The total difference between 74 and 28 is 46. And again, I would do lots more examples. This is normally something that I would do with primary 5. And then I would do lots more examples. And finally, I'll jump to one like this. I'll say, okay, let's do this one now. We can't draw 612 dots or 187 dots. And the 100 square doesn't go up to that. So we're just going to have to think about it. And then I'll say, okay, right. I've only got 2 kind of reference points here. What do you think my first reference point is going to be? And there is more than one correct answer, but I always try and encourage the children to go to the nicest, friendliest number they can find. So in this case, I would go to 200 and I would go to 600. And then I would say, okay, what is that? What's the difference between 187 to 200? It's 13. What's the difference between 200 and 600? It's 400. What's the difference between 600 and 612? It's 12. So what's the answer to the question? Good. I'm sure you all shouted 425 there. So you can see that's why it's quite a useful strategy. But again, obviously I'm only focusing on one strategy here for the purpose of this presentations. I wouldn't use it for every single question strategy. So if the question was 102, take away 3, we wouldn't be doing counting up from 3 all the way to 102. 102 take away 3, we'd just be looking to take off the 3 in that case. So again, it's good for children to have 2 or 3 strategies that they're confident with, that they can go to for, depending on the context, what strategy they're going to apply to what context of numbers it is. Right, so that's subtraction. So again, hopefully you can see, I'm just going to go back a slide or 2. Again, the importance of the subitizing within all that. Again, so if they're not confident with their subitizing, then this is a wee bit more difficult. Right, so what we're going to go on to now is, I need to slide on a few slides, is we're going to look at the big grid. So the big grid is a part of the numeracy blueprint board, and it's basically a 10 by 10 grid. And it can be used for lots of things. But one of the things that I use it for is drawing dots, surprisingly. And I'll say to children, okay, copy what I've just done. What have I just done? You've drawn 3 dots. Good, let's write 3 at the side then. What have I just done? You've drawn another 3 dots. Good. How many dots do we have now? 6. Good. What have I just done? You've drawn another 3 dots. Good. Now we've got 9. What have I just done? You've drawn another 3 dots. And then I'll stop. And I'll say, right, what am I doing right now? You're drawing a nice pattern. Yes, I am. You're drawing dots. Yes, I am. You're adding on 3 each time. Yes, I am. You're drawing groups of 3. You're counting in 3s. You're drawing the 3 times table. Good. We're drawing the 3 times table. How many groups of 3 do you see? I see 4 groups of 3. Good. How many dots? 12 dots. How many groups of 3 do you see now? 5 groups of 3. How many dots? 15. And then if I stop and say, like, how many dots are there? So notice I've not asked how many groups of 3. I've asked how many dots are there this time. I've asked that first. There are 18 dots. Good. How many groups of 3 is that? That's 6 groups of 3. So by depending on what question you ask first, how many dots are there? Or how many groups of 3 are there? You're either saying 18, how many 3s make 18? 6 groups of 3. So you're kind of leaning towards division. How many groups of 3 are there? 6 groups of 3. How many dots is that? 18. You're leaning more towards multiplication. And they can keep going, keep going, keep going. And say, what do you notice? Blue, red, blue, red, blue, red. Good. What else do you notice? Oh, the reds are the even numbers. The reds actually counting 6 numbers. Is the 3 times table finished? No. Yes. Is it finished? No. When does it finish? 12. I'm just pretending I'm pupils right now. Because sometimes they do the shape, they say it's they say it's 12 because most of the pictures they see or posters around the schools and stuff like that, or on any website they go to, the 3 times table, or the maximum it will go to is 12. But of course we know that it goes beyond that, and so will most of the children. The 3 times table goes on forever and ever, never. And one nice thing to do is write down the stations of the 3 times, or the table. So we're saying 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3, 6 groups of 3. Notice it's the number of groups that's changing. So 1 group, 2 groups, 3 groups, 4 groups, but the amount of 3 in each group is staying the same. So you're trying to reinforce that multiplication is just repeated addition. So if I do know 7 3s are 21, I know 8 3s is just adding on 3 more. If I do know 10 3s are 30, 11 3s is just adding 3 more on. And obviously a very nice thing to do is draw on the 100 squares. And again, we talked about patterns on the 100 square. Is to start circling the stations of the 3 times table on the 100 square and say, what do we notice? What do you think is going to happen? What if we continue the pattern? What's going to happen? Well, I can start to see a wee diagonal pattern. Yep, the diagonal pattern happens all the time for the 3 times table. And again, you might want to point out, why did I highlight these ones red? Because that's my total 10. So that's 10 3s. That's 20 3s. That's 30 3s. What's the pattern? 3, 6, 9, 30, 60, 90. 3, 6, 9, 12, 30, 60, 90. What's next? Now, obviously, we could repeat that with all the tables. I'm not going to do that. But it's a nice activity to look at. When you start to look at any times table, I would always start by drawing dots so the children can see, right, what is the 4 times table? Isn't it just, or 3 times table? 3, 6, 9, 12, 50. It's not just memorizing the stations. What does it actually look like? Well, it's a build-up of 3 dots, 3 more dots, 3 more dots, 3 more dots, and so on. And I do this activity with primary 3. And I do that activity with P7. Now, you might be thinking, why you did it with P3 and P7? Because with P7s, I just like to remind them. But with P7s, I ask them this question. Right, have we learned all our tables? What's next? What can we do with our tables knowledge to make more complex multiplication questions easier? Well, let's have a look. So I might say to them, right, I want to know the answer to 14 times 3. So I need to identify 14 groups of 3. So on the screen's 20 groups of 3, but I want to highlight 14 groups of 3. So there's 10 groups of 3. I need an extra 4 groups of 3. How many dots are in the yellow sections? Well, there's 30 in here, and there is 12 in there. So 14 times 3, the answer must be 30 plus 30 dots plus 12 dots, so it's 42 dots. Right, but we don't want to have to draw pictures or dots out every single time we do 14 times 3. Is there a nicer way we can record this? So I like to draw a rectangle, or you can call it like an area model. So we had 14 groups of 3, so I'm going to write 14 at the top and 3 at the side. But when we did the 14 groups of 3 on the big grid, we had 10 groups of 3 and 4 groups of 3. So I'm going to split my rectangle up into the same. I'm going to have, instead of having 14, I'm going to split up into 10 and 4. How many dots were in the 10 times 3 section? 30. How many dots were in the 4 times 3 section? 12. How many dots is that altogether? 42. 30 plus 12, 42. So again, this is a much more condensed way to do it. Obviously, we don't want to draw dots out all the time. The dots are great for helping us understand this process, but we can quickly draw one of these kind of rectangle models out without having to draw the dots out. But it's good to have the dots there to help us understand. So we'll try another question. Okay, we're going to look at 26 groups of 3. So let's identify 26 groups of 3. 10 groups of 3, 10 groups of 3, and I need 6 groups of 3. How many dots do we have? Well, we've got 30 in here, we've got another 30 in here, and 6 groups of 3, that is going to be 18. So 30 dots is 60 dots, 18 dots gets me 78. But again, I don't want to have to draw 78 dots out to work out the answer to that. So we're going to look at a rectangle model again, where we've got 26 up at the top, 3 at the side. We're going to split the 26 up into 10 groups of 3, 10 groups of 3, 6 groups of 3. How many dots on the first bit? 30. How many dots on the second bit? 30. How many dots on the last bit? 18. What do we do with those numbers? 30, add 18. The answer is 78. So now we're getting confident. Can we just try a question without drawing the dots? So again, if you're sitting with a bit of paper, it's maybe good you can participate at this point and draw the rectangle. We've got 17 up the top, we've got 4 at the side. When we draw 17 groups of 4, if we did draw 17 groups of 4 in the big grid, we'd have 10 groups of 7, we'd have 10 groups of 4, then we'd have 7 groups of 4. So we're going to do the same here. 10 groups of 4 and 7 groups of 4. 10 groups of 4 would get me 40 dots. 7 groups of 4 would get me 28 dots. Answer to the question, 68. Let's try another one. Sorry, I'm just going to point out one thing. When I times by 4, 40 popped up in here. When I times by 3 earlier on, 30 popped up in here. Right, so let's see if that keeps happening. Which it will. So 24 times 7. 24 at the top. So again, let's do this one with me. 24 at the top, 7 at the side. What we're going to do with the 24, we're going to split it up into 10, 10, and 4. Do you know 10 sevens? Yes. Do you know 10 sevens again? Yes. Do you know 4 sevens? Yes, hopefully. Do you know the answer to 24 times 7? Well, it's 70, add 70, add 28. 168. Who got it right? Nobody, no thumbs up. Whew, a thumb up. A few thumbs up are coming now. Good. Starting to worry there. Oh, loads of thumbs up there. Right, good. Now, 24 times 7. Obviously, I've split it up into 10, 10, and 4. The natural step would be, and again, I wouldn't push this on a child to say you have to do this, but the natural step might say, well, we don't have to go 10, 10. We can go straight to 20 and 4. which means we don't get 2 70s, we get 140 instead. So that's a kind of natural progression. But again, if our children just start studying this or looking at this, they might be quite happy with the 10-10 bit. So until they're ready to naturally take that jump themselves, kind of just let them stick to what they're confident with. Right, now, when I multiply by 7, 70 popped up, right? So we talked about that. When I multiply by 4, 40 popped up. When I multiply by 3, 30 popped up. Multiply by 7, 70 pops up. Multiply by 8, 80 would pop up. Multiply by 9, 90 would pop up. So I call that the key number. And we're finished with multiplication now because we've spotted the key number, because the key number when working with 3 is 30. Key number when working with 4 is 40. Key number when working with 7 was 70. Key number when working with 8 is 80. Key number working with 9, 90. And the key number for working with 13 would be 130. Good. So if we understand that, then we can apply this strategy for division. So we're going to look at 51 divide 3. So I'll draw a new rectangle. 51 divide 3. Now, you don't have to do this bit right now. You might just want to wait a second and look at it. But 51 is going to go in the middle. And because I'm dividing by 3, I put that at the side. But we remember that 30 was a key number. So we're going to split this rectangle up. Instead of having 51, we're going to split it up into the key number, which is 30. But remember, it was 51, wasn't it? So we have to still make it 51. So that other bit has to be 21. So now instead of dividing 51 by 3, we can do 30 divided by 3, which is 10. 21 divided by 3, which is 7. So what's the answer to this question? 51 divided by 3, well, it must be 10 plus 7. So the answer is 17. And that's just using that key number. 72 divided 4. What's the key number? The key number is 40. So either we're starting with 72, I'm going to quickly split up the rectangle and make the key number, because we're dividing by 4, the key number is 40. What's left over? 32. 40 divided 4? And that bit's always 10. 32 divided 4? 8. Answer to our question here? 18. 72 divided 4 is 18. So let's look at 2 more. 72 divided 3. So again, with this one, I would start with 72 in the middle. But this time we need to be careful because we're dividing by 3. The key number's 30. But 30 actually fits into 72 twice. So because it fits in twice, I would put it in twice. So we've got 30. We've got another 30, which takes me to 60. What's left? 12. So now we divide all of them separately by 3. 30 divided 3, 10. 30 divided 3, another 10. 12 divided 3, 4. What's the answer to this question? 24. Good. Hope you're feeling confident because you're about to get a question yourself now. So 91 divided 7. Have a go at that one. At home, we'll have a drink of water. So 91 divided 7, key number, 70. So split the 91 up into 70. What's left? 21. 70 divided 7, 10. 21 divided 7, 3. Answer to the question, 13. Right, good, a thumb up. I like a thumb up. Good, yes, lots of thumbs up. Brilliant, good. Right, yay. Somebody's fancy can do multiple ones. Right. So one more last question on this. I'll let you again start this yourself. 156 divided by 13. So again, we draw a rectangle out. Quite quickly, we know we're going to rub out the 156, so we don't actually need it. And to start with, Because I'm dividing by 13, the key number when working with 13 is 130. What does that leave me? 26. 130 divide 13 is 10. 26 divide 13 is 2. Answer to this question is 12. Good. Now, hopefully, if I talk about learning something new, if I were to ask that question at the start of 4 o'clock today, 156 divide 13, how many people would have known to kind of do that strategy and do it quite quickly without doing any, I'm going to put in inverted commas, sum, right, or algorithm or bus stop thing and anything like that. But, and again, the more we use this, then the more times we use that strategy, then the better chance it is we can actually picture it in our head. So with some questions, eventually hopefully say, well, actually, I don't need to draw the bar model. I can see the key number, I can see what's left over, and I can piece the answer together. Right, so on to the last wee section. So we're at 12 minutes out. So we're going to do a wee bit in fractions and percentages to finish with. And this won't take that long because it's all kind of picture orientated. So when I'm doing fractions, I draw rectangles. And what I get the children to do is say, how many boxes are in that rectangle? I'll get them to draw the same rectangle. Say there's 12 boxes. Good. Let's put 4 dots in the top row. How many of the squares have got a dot? 4. How many squares was there? 12. So how many have got a square? 4 out of 12. But we can also look at the shape as 3 rows. Does the top row have dots? Yes. Does the middle row have dots? No. Does the bottom row have dots? No. So how many rows have got dots? 1 row out of 3. So if I can describe the dots as 4 out of 12 or 1 out of 3, 4 twelfths or 1/3, then these two fractions must be equal fractions. They must be equivalent fractions. I can put another 4 dots and say now we've got 8 twelfths of the squares have got a dot. But that's the same as 2 rows out of 3. So 8 twelfths must be equivalent to 2/3. I can put dots in everywhere. So 12 twelfths equals 3/3, which now equals the 1 whole rectangle. And then we can change it up to a different shape. We can say, okay, now we have 5 by 4 rectangle. So that's 20 dots. So let's put 5 dots in the top row. So that's 5 out of 20 or 5 twentieths. But it's 1 row out of 4, so it's 1/4. So 5 twentieths is equivalent to 1/4. I can put another 5 dots and say now it's 10 twentieths, which equals 2 rows out of 4 or 2/4. But that's also equal to 1/2. We can see we've got 10 dots and 10 empty spaces, so it's half and half. And finally, we can put another 5 dots and say, okay, now we've got 15 twentieths, which equals 3 rows out of 4. So 15 twentieths is equivalent to 3/4. And then finally, we can go into percentages. I can say, let the big grid equal 100%. If the big grid equals 100%, what does that one box represent? It represents 1%. So then we can start to investigate. I've half the big grid. How many boxes are in each side? 50. So a half must equal or be equivalent to 50%. What have I done to the big grid now? I've quartered it. I've highlighted the top quarter. So I've shaded 1/4. What percent is that? How many boxes is that? So 1/4 is equivalent to 25%. There's been 3/4 left blank. So it's 3/4 equals 75%. And then we can start to look at other bits of the big grid as well. We can say, well, I can chop the big grid up into 5 sections. I can shade 1 section out of 5. I can shade 1/5. And I can see 1/5 is equal to 20%. 4/5 are left blank. And that's equal to 80%. I can shade 2/5 this time and say, what percent is that? That's 40%. 3/5 are left blank, which is 60%. So, just before we go into the questions, that's has kind of ran through quite a lot of stuff. Just to let you know, obviously, counter us what I do. We do school CPD or CLPL. We also do obviously council or cluster CLPL. I do classroom workshops, so I can count into your class, your school, and work with every or as many classes you want me to work with for like half an hour, 40 minutes each. Do parent workshops as well. And obviously we've got this Numeracy BluePrints resource, which you can, based on other activities we did there today, you can do on the Numeracy BluePrints resource. It's good just to have kind of everything on the kind of one resource that you can just have in front of the children there. So hopefully we've met those aims and objectives. Upskill pedagogical knowledge around numeracy, increase awareness of visual and active learning activities like concrete, pictorial, abstract.